All right, so question 5, we are completing a proof. It's a lot of reading, but it's not that bad. It just looks like a long one. So parallelogram A, B, C, D, E, and then we have point E, and then there's all these statements we need to complete. So complete the statement to determine if the diagonals of A, B, C, D are lines of symmetry. So the diagonals are these lines that go from corner to corner. Since they bisect each other, showing that they are perpendicular to each other would be sufficient in showing that they're lines of symmetry. If they are not perpendicular, then they are not lines of symmetry. So the diagonals of a parallelogram bisect each other. So they cut each other in half. That's what bisect means. So, and then there's some drop down boxes. So let's just label what we know about this parallelogram. I'm going to move it and try and get a split screen going here. Okay. Let's put me up there. So when the diagonals bisect each other, AE is congruent to EC. Those two lines on each side of the midpoint are congruent, and it goes the other way too. BE is congruent to ED. So that's what it's asking for. So BE and AE, no, you're looking from endpoint to endpoint. So BE, AE. Those are separate lines, they're not congruent. BE is congruent to, oops, I was on this one, to DE or ED. It doesn't matter which way you go. It's the same endpoints. That's all we're looking at. So that one. And then here, A to E, right here, is congruent to E to C or CE. Okay, we can flip those if we need to. So it looked confusing. There were a lot of options. It's just asking for which lines are the same length. Okay, we know the opposite sides of parallelograms are congruent. So let's go here. And I want some different colors, so I'm moving over. So it tells us the opposite sides are congruent. So this side is congruent to this side, the opposites. And this side is congruent to this side. Okay, so AB is congruent to DC. And AD is congruent to BC. And now we just need to find those over here. So this is saying AB. So the very top of my parallelogram, now I'm going to look at the bottom. That's DC or CD. Now I'm looking at my other side, A to D. So the other side that's congruent is CB or BC. The order doesn't matter as long as the endpoints are right. Okay, let's look what's next. Whoa, since AE is congruent to CE, that's what we found up here. BE is congruent to DE. Hey, we could have just copied. AB is congruent to CD. That's what we found here. And then triangle ABE. That's how we read that. So triangle ABE, let's find it. ABE. So it's saying this triangle is congruent to what triangle? Look at the sides. 2, 2. Look at my tick marks. 1, 1, the base. It's congruent to this triangle. So we're going to find that triangle in our drop-down box. EDC, CED, the order doesn't matter. It's just the letters have to be right. So not D, A, no A, C, D, E. Yep. By side, 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 because like I just went through, all the sides are congruent. That's what side, side, side means. Then we're going to do the same thing. Since AE, CE, yep. DE, BE, yep, we found that up there. AD, BC, we found that up there. So now we're looking at a different triangle. We're looking at triangle ADE. That's right here, ADE. This triangle is congruent to this one. So we need to find BEC in our drop-down box. Those are congruent because those also have 3 sides that are the same length. So BEC, CBE, right? Just find the right letters, not the order. Okay, we're almost done. If angle AEB and BEC are supplementary, it can or cannot be shown that they are corresponding congruent angles between congruent triangles. So they are not guaranteed to be right angles. Okay, so I need to erase this because I've marked all over it so I can see what we're talking about. So angle A to E to B. So that means A to E to B. So we're talking about this angle right here. Okay, and then we're comparing it to angle B to E to C. B to E to C. So we're comparing it to that angle. So those are 2 angles on a straight line. What do we know about 2 angles on a straight line? They add to 180. So those are supplementary angles. And it tells us that they're supplementary. So it can or cannot be shown that they are corresponding congruent angles. So if they're supplementary, they add to 180. They are not congruent. Okay, those are not congruent angles. They're not corresponding. So they are not perpendicular. Perpendicular means they'll both be 90 degrees. They're not congruent. Woohoo! So that one takes a while, but it's just going through our properties that we know of parallelograms.